Okay, cool. So Nelia, thank you for that. So let's when I think that is probably how it will be for this exam as well. That then that the stats one is just the one that is for odd one out at the moment. Yeah. So let's hope it is like that. Weird time that you guys are writing. So that is like an evening slot. So is it also then they don't give you certain times to log on during the day? It is basically probably then from you can log on from quarter to get a few extra minutes and then write 2 hours, I assume, with a split in the 12 or 13 questions and an hour for each nearly. Okay, so let's start with okay, yeah, so till hoi, okay, good luck. That is like a late night session. Okay, so let me share my screen when we can run through some of the integration work still. And let's see how quickly we can do that, and then hopefully there's time to still look at one of the previous papers, but else just that we have at least sorted all of the study units out. After today, they will reschedule this meeting again to Monday. So we will have a session on Monday and on Tuesday. So I've asked them to schedule just 1.5 sessions on Monday and Tuesday for us to do exam prep and those kind of things. So my focus nearly for today is just want to get through all the work, and then on Monday and Tuesday we will do exam prep. Okay, and how I wanted to do on Monday and Tuesday is basically the Monday session we'll do the first 12 or 13 questions, and then the Tuesday session we'll do the rest of the questions. The exam is 30 questions, sorry. If somebody can just quickly, why am I now thinking it's 25? Is it 30 questions? It's normally 4 minutes per question. Yeah, okay. So we'll basically then on Monday do 15 questions, and then on Tuesday do 15 questions and see how quickly we can get through that. Okay, so I'll go through last semester's paper for you guys if that is fine. Else, if you have another paper that I need to go through, you can ask me and send it to me. But I think last semester's question will be quite in line with what you will get. Also, there has been a move away from none of the above options. So in last semesters already, all of the questions were, there wasn't a none of the above included in the set of questions. So I think that already is a move in the right direction. Okay, so let's start with the ending off of the integration part. So last week we looked at, I think it was last week or the week before, we looked at some of the beginning of the integration, and we looked at the power rule. So now I quickly want us to look at where we need to basically do some substitution in the equation. So normally it is a formula that consists out of two parts, so that you can't just say like the normal process that we would integrate. So, but remember we did this in differentiation as well. So, and also what they say here is when we look at the substitution, so it nearly is the reverse of the chain rule of differentiation. So just nearly keep that in the back of your mind. So what we will need to do is we'll create that as a variable. So we will say 4x plus 3 is equal to something, and they, again, like the u, if there was two terms, they would have made the other one v. That is just, I think, nearly a standard what it has been used throughout the DSC1520 module. Okay, so then basically what we need to do is say, well, we need to integrate u to the power of 3. So let's say that is now your new function. So we need to integrate that. Okay, so by doing that, and we can follow the process here as well, but basically you're going to do two things. So you will need to integrate that part. So integrate this part of the equation, and then you will need to integrate the other part. So let's just quickly, and let me show it how we're going to do it. So, and I think what is also important is we need to look at this equation as well. So the first thing that we need to do is to say, okay, so look at the du, integrate it with dx. So like that they did here, equal to 4. But with that, we will not be able to do anything. So like if we had, say, x over y is equal to 4, to get the x on its own, we multiply by y on both sides. The same you can do in this instance. So if we multiply both sides by dx, the dx on this side will fall away, so you will sit with du is equal to 4 dx. Okay, so that is just out of maths that you can do that. So there's nothing funny being done here. It is just purely, as in all math problems, if you really want to get rid of a thing that you divide by, you just multiply it with both sides, on both sides. So now we sit with that formula, but we actually want to get the dx. So at this point, it was very difficult just to get to the dx, so that is why we multiplied it out. And then for the next step, to get that on its own, we need to divide by 4 on both sides. So then you will get that your dx is equal to du over 4. Okay, so basically the one component has been dealt with, but now we need to say we're basically integrating so let's just write that because that was your original. I'm just going back to the original. So that is what we needed to do. So remember now we have the u to the power of 3 over 4. Okay, so we basically substituted that dx with du over 4. That comes directly from there. So we substituted it in the formula. Okay, and now we need to multiply out. So the first thing I can do, and that is nearly if we go back way at the beginning, what we can do with a constant. So a constant can be taken out. So I can put the constant in front. So that is then my next move. And then it is to say, okay, well, constant in front stays there. If I integrate that, what do I do? Basically, u3 plus 1. So the same way that if it was an x or whatever we would have done. So let me just make it a bit clearer. Let's do it like that, 3 plus 1. And whatever is in the 3 plus 1, whatever that total is, so that's 4, we will need to divide by 4. Okay, so basically with that I'm sitting with u to the power of 4, and below the line it's 4 times 4, which gives me 16. Okay, so that is nearly that covered. What we need to remember is we don't know again if there was a constant. So just remember always to add the c for the constant. And then the next thing is check what is the answer. So if the answer is written in terms of u, that would have been your answer. If the answer is written back in the form with the x, you then need to substitute the u with that form. Let's just make it with that again. Okay, so if, and that for me is purely check what your answer is. If your answer is written in u, don't even go to the next step. But if it is written in the x formula, you will then need to say, okay, replace the u by what I did at the beginning. So it is 4x plus 3 to the power of 4 divided by 16 plus c. And again, if there is an option of only that and the option of plus c, always take the plus c, because you don't know if there was any constant when you did this, or when you started off. So I think that is the important thing. If in your answer set nearly, if there's one without the c, always choose the one with the c. So if you then need to guess between one or two of the options, always go with the one with plus c. Okay. So that is the integration by substitution, and you will see that there's nearly a few of those in here that are examples, and it's every time, unfortunately, that it's not an easy one. So again, here you need to substitute the 2x minus 1. So let's do that. So in here you would have needed to substitute it by, so again, using u, so again, if we look at this component, du over dx is equal to 2. So let's and nearly I don't want to say a trick because it's, but nearly how I look at this sometimes is, so let me, I don't want to confuse you, but sometimes how I like to do it is nearly want to say across kind of, so, and please don't, don't, I nearly want to say this is more tip, to save you time. But if you basically have that, so you say dx divided by 1 is equal to du divided by 2. So basically you say that divided by 1 is on this side, that divided by 2 is on this side. So that is just something that I've nearly taught myself. There's no mathematical sense in it. It is just an easy way nearly to see it. But else, you can go through the process to say, okay, I multiply out on both sides with dx. So on both sides, if I multiply it out, I will get this, and then to get dx on its own, on both sides I will divide by 2. So in essence, I will then sit with dx that is equal to du over 2. Okay, so this is not somewhere in any literature. It's just something that I nearly taught myself to sometimes just get a quicker method of getting to the answer. Then the same process that we would have followed is, so we still need to nearly solve this. So we still need to solve that. So the original is still the f of x is still that. So let's just write down the original, and then let's start substituting. So the 2x minus 1 I can replace by the u. The dx I can replace by du over 2. Okay. Then 10 divided by 2 is 5, which is a constant. So I can take the constant in front. Then on this side, I left with 1 du, 1 over u du. Okay, so then if you look at this, we've learned out of the differentiation, if you had ln of u, it becomes, or if you had ln of x, it becomes 1 over x. So if you have 1 over x and you integrate it, it becomes ln of x. So the same in this instance, 1 over u becomes ln u. And then always add the c. So at this point again, check what is in the exam. If they're writing it in the process or in the terms of u, keep it like that and you get to the answer. But if they have replaced it by x, you basically can do the same. And you don't need to, they will not have an answer where you now needed to simplify it further. So there will not be something weird in this that you'd suddenly sit with 2 or 3 terms to simplify it. So that won't happen. So don't nearly worry about it. Will not get to that extreme. So it will only be that you need to substitute it back into original. It won't be that now suddenly you get something again that you need to simplify. That will not happen. Okay. Questions up until now that we just, because I think it's nearly the same process that follows for all of these ones. It is basically going to be the same. So every time you just need to say u is equal to whatever the function is, and you can see it every time it is the same thing panning out. Okay, so you can look at, so in here, the second one again. So yes, we have something to the power of, but we will look at that, and that will become u. And then one of the rules, way back, when did we do that? About 2 weeks ago. Anything to the power of u, if you integrate it, it stays the same. So the only thing that actually had an impact was that 5x over 5, that became 1 over 5. And then you just add the c, and you will see it in every one of these. Add a constant. Add the constant. Add the constant. So that for me is nearly every time. Remember to add the constant. So when you get your integration question and there's one without the C, automatically nearly eliminate that out of your options. Just that you have less options to look at. So what I would normally do is what I've been seeing with a lot of other exams as well. A lot of times they give you the option like this with the C and the same option without the C, and then two other options. So then I would nearly always say, okay, but let's pick that one nearly in the back of my mind, already cancel that one out, but let's then work a bit through it and see if we actually get to that the same answer that I nearly would have guessed. I think that is nearly how I normally look at these, is to say that there are normally one or two that you can eliminate from the start, and then let's look at the rest of the questions. Okay, so let me just quickly, so what was different in this one? So again, we have the 3x plus 4, so we will make that u again. So the difference in this one was that because of the square root, somewhere we will have it to the power of a half. So the question then again for me is not just really in what you need to do, but when you get nearly to the end of that question or that answer, you would see that again, please check what is the answer that they give you in the exam, so that again both of these are correct. So if they give you it back in the form with the square root, and the option is with the square root, then you will need to go to the final part of that answer. If they give it to you without the square root, then you need to know that your answer and the one that's the factorial will be divided by 2. So nearly, if this answer was also 2 over 9, with the rest of that, both of them are actually the same answer. And then it is just depending on what is in the paper, which one you decide then to go with. So if both of them are in the paper, both of them are right. So it's not that they can give you both as an option, and said no, they wanted the last one, because actually both of them are correct. So it is just what do they want as the final option. Okay, so in this one, what was different is, so again, we'll make the one part equal to u, but look at, so du dx, du dq. So when we work with this, and again, automatically nearly you need to, if you divide by something, nearly start thinking of, you will need to have a ln in this process. And that is nearly the link here is, in your answer, you will probably have a ln. So when in the exam, when you get something like this, automatically you can nearly say, in my answer, there must be a ln 8q plus 1. There will be a few other things as well, but that needs to be in your answer automatically. Just because it is 1 over something, so it automatically becomes ln of what it's nearly divided by. So yes, there is a few things added to it. The C is added. The 1 over 8 was added because it was part of that process. But, and this is more tip again, if you see 1 divided by something and you need to get the integration of that, in your answer, it will be ln with that something that you divided by will be in brackets. Okay, so again, more of a tip to make it easier for you in the exam. Okay, so before we get into this one, quick, is there questions around the few that we just did? And you can unmute as well. We only a few students, so please, if you want to unmute, you can. And is this helping? I don't want to confuse more if it was something that you already knew nearly. Okay, so please, you can unmute, otherwise we will continue. Okay, cool. Okay, so let's look at the next one, and this one was a bit more difficult. So if you can look at these terms, you can see it is much more difficult, but it's nearly to say, okay, I've looked at it and I'm like, phew, okay, I need to probably do something with the x plus 1. So the x plus 1, I will need to say u is equal to. What's interesting about this one, so at this stage it looked difficult. And now interesting, there's no ln, but let's see why not. So at this stage it looked difficult. But we need to simplify it. Okay, and then if you simplify it, you will see that this equation looks quite different from all the other normal equations. So then, because it is a plus between the two, remember, and this is now taking us back to the beginning of the chapter nearly. What we will do in this instance is do the integration of this one plus the integration of the other one. Okay, so we will basically do 2 integrations. And that is why you will see, so in this instance, we will then replace it by u and follow exactly the same process. So that is the process for that one, and that is the integration for that one, and then always add the c to it. Now again, if you integrate that, you get a value. If you integrate that, you'll get a value. When you need to replace the U with the original, here you don't have the U, you just continue. So again, this answer and this answer is exactly the same. So then again, dependent on what they have as the options for you, you need to decide. So it can be that, and I've seen it in one or two papers, that they give you to the power of whatever the function is. And in a few papers, I have seen that we do the square root as well. So it is nearly, for me, you will just need to check the answer set, what is the options that they give you there. Because again, both of these two are correct, and both of them can be your final answer. So again, it's dependent on what is in the exam. Okay, so nearly the last one, and here again, we divide by a function. So we will have that function again on its own. So again, we're going to make it u. So when we then divide by u, you will have the ln. So automatically again, we can go from that you will have ln. So remember when I said in one of the previous one, in your final answer will be ln of what is ever there. So again, you will again have it in your answer set. Okay, this one just would have been worked out a bit differently because of the 2 and the 8. The 8 coming from that part, but basically the main part of the function will include a ln 5 minus 8y. So again, if there's a few options for you to check out, nearly again a tip to look for the one that says ln and that in brackets plus the c. Okay. So basically what we've been doing is nearly, and I just want to see why this is so weird. So what the next step nearly is to also identify areas. So how big is the area under the curve? And the reason why we're going to do that is that you will have an equation for the marginal and the revenue. So for your consumer surplus and producer surplus for a quadratic equation. So in study unit 4, I think it was 4, we did the linear equations, and when we had the consumer and producer surplus for that, and we basically calculated the area with the formula of a half times base times height, because that was nice in the between two straight lines that forms a triangle. So it was very easy to calculate that area. What we need to do in the instance where we work with quadratic equations is, let me just make that a bit smaller. So with a quadratic equation, you can see there's no place nearly where I can say, okay, up until there it's a straight line. Okay, I can calculate that part. I can calculate the other part. There is nothing that's easy there to calculate. So what we are doing with a quadratic equation is we integrate the equation, and then whatever answer we get out of that integration part, we will put in numbers. So your equation will be have x's, or it will have other variables in it. But basically what we will then do is we would say, okay, for x of 5 and x of 1, we will need to calculate that area. So we will basically get the integration of that function, because the integration of that function will give me that area. So in actual fact, how it works is, so let's just do it. So if I integrated the function, you would nearly have this whole area would be part of that integration. But then we will need to get a and a b value. So they would need to tell us those values. So as in the linear equations, they would have told us at price equal to 10 or quantity equal to 15, what is the consumer surplus? So when we get to that later on in the session, that is basically, they can't again just say work out what it is by just integrating this formula. They need to give you a bit more. So the same year, they need to tell me what that b value is and what that a value is for me to calculate that area. So they need to tell me the b and the a, and then I can calculate that area. So how it works is I will integrate my formula. So basically x to the power of 3 divided by 3, that one will become 2x to the power of 2 divided by 2, so it becomes x to the power of 2. That was x to 3x, and for completion's sake, we put in a c, but actually the c for this is not going to make a difference, because when we put 5 into the x's, we will get the answer. So in the end, it will be that. When we put 1 into the x's, in the end, we will get that. Because you put the 5 in the x, the c never got a value. So you will see in this instance, the c is just taken along in that equation. It's been taken along in that equation. And because it's going to be a minus c will give you 0. So when you work it out, you actually don't even need to worry about the c, because you're not going to show it in the exam as proof of how you got to the answer. So for me, nearly the important thing is you will need to know how to integrate that formula. They need to give you that formula that you need to integrate, and they would need to tell you find the area between 2 points. Again, they can't leave that open for you to guess. So they need to tell you. So I think that is just important. They need to tell you what those 2 points are that you are calculating the whole area for. Okay, so I just wanted to make that nearly clear that you need to integrate. They need to give you 2 points, and basically with those 2 points you will work out the area. I think maybe there's one that we can look at as well. So they just went from that graph to show you how it would look like. So between points 1 and 5, that was the area that you have calculated. So what they also want to show you is there's different things happening in the different areas. So depending on what you are working out, you just need to make sure if you basically, so in this part, you substitute or subtracted the one from the other one to get to there. So what you actually did, and that is maybe what I need to show you. So what you actually did was that with a 5, you calculated or you worked out that whole area up until the 0. So with the 1, you're actually calculating that area. So let's see if that color will work better. Okay, so that is why when you subtract the 1 from the 5 from the areas, that is why you will end up with that portion. Okay, so that is what is happening in this instance is you have the whole area that you calculate, and you're basically subtracting that part so that you can get to the part that's between 1 and 5. So when the formula looks like this, now you need to, and I haven't seen this really in the exams, but I think it's just so that also that you know. So if you now set that minus that, you would get a different answer. So in this instance, you would have needed to add the 2, because this will already give you a negative. So again, just depending on what the area is that you are looking for, just make sure what you are working out. So again, how I would normally do this is I would draw for myself a sketch, and we'll do that with the consumer and producer surplus as well, because again, I work much easier when I see something visually. So I would draw the visual part of that and just look at that as well. But this is nearly leading up to a part of a consumer and producer surplus that we will need to do. So I just want to see, it is probably in the next section. So let me just again show you. So another equation was this one. So we first need to integrate it. So these ones are now nearly the, as I call it, the double whammy of these equations, because it is not as simple as that. It is asking you to nearly remember what we did at the beginning of this session. So you need to integrate that part. So that integration will need to be done in the process that we did with these. So you will need to follow the same principle, and then you will need to, the answer that you get, you will then need to say, so they tell us you will need to look between 0 and 2. So you will then need to put it between 0 and 2 and work out your answer. So these are the, nearly in a sense, the most difficult ones, because you need to do the original work we did at the beginning of a substitution, but then you also need to add the component that you need to work out the area. So these ones are for me the most difficult, because it tests that you can do the substitution. The same with this one. Again, there you will see the 1 over x, so there will be a ln involved in this one, but you now needed to basically integrate. This integration was a bit easier because that one you can integrate on its own, that one you can integrate on its own. It wasn't like this one that is part of a formula. So this one is actually a nice one, because you integrate that, which will give you x to the power of 3 over 3. Integrate that, so integration of 1 over x is ln of x. And okay, this was where the mistake was. Okay, so just this was a mistake. Okay, so you will see in the rest of the formula, by using the plus. So just want to highlight this to you. It's not because anything that you did with the integration here, that was actually a mistake in the book. So that should have been plus. So there's no rule that made, when you made the integration of a plus, of a minus 1 over x, that it suddenly becomes positive. So that was a typing error. Okay, so just if you went through it and were wondering why suddenly when I had minus 1 over x, it became a positive ln of x, that was a typing error. It should have been positive 1 over x. So there's no rule or in mathematics that makes it, when it was 1 or minus 1 over x and you integrate it, that it suddenly becomes positive ln of x. Okay, so please, that was a mistake in the study guide. Okay, so this one was nice because you had that as one term, you had that as the other term, so we can integrate both of them. And in the end, we just needed to add the C, but the C is not going to make a difference. And then you basically, for that, you're going to replace it by 1 and 0,2. So again, we follow the same process. So you can see here as well that it was everywhere the plus. So just for that, that was where the mistake was in the text or in the study guide. So I just want to reiterate, there is no rule or nothing that makes a -1 over x, the integration of that, suddenly become positive ln of x. Okay, so just there was a mistake. Okay. Okay, and if you needed to draw the two, you will just see that it's very similar, nearly kind of. It's just swapped around, but basically they won't expect you to draw it. They can't really ask you to draw it. I haven't seen in a paper yet that for this they ask you to say which one is the right formula. So they would rather give you the break evens and the linear programming than showing this on a diagram and ask you between A, B, C, and D. Okay, so definitely not to worry about how you draw it and things like that. So for me, the more important thing is you will need to know how to integrate the formula, and then you need to know how to put in the two values that they are referring you to get to the area. Okay, does that make sense? Happy with that? Questions before we go to the last study unit? So quick check-in. Okay, Nelia, happy? Eva, you happy? Tasneem, you happy? Okay, it's yeah. Don't worry. As long as I haven't confused you even more. So as long as it helps a bit, and yeah, and go through the recording again. Hopefully it will be up and running very soon over the weekend already. Yeah, and just I nearly never in all of these I never showed you. So basically that part, yes, always. Always biggest number at the top. So it's always from big to small. Always like that. So there's no, so, and that may be, again, one doesn't know how some of the papers are always set up, but if they have in the paper that they said select the one that will be best represented and they swap it around, then it's wrong. So it can be that sometimes they ask you one or two of these formulas that they've nearly recreated. So if that was swapped around in the exam, you know that one is the incorrect one. So it's always positive or the biggest one at the top. Okay, so just a quick quick before we go to what I haven't nearly talked about is how do we get this one every time. So it is basically the 2x that is differentiated. So if I differentiate 2x, I get 2. If I differentiate 5x, I get 5. If I differentiate 3x, I get 3. If I differentiate the 8q, I get 8. So that is, I don't know if I have talked about it nearly, I just went into it. So differentiation of x is 1. Let's quickly just go through them. Differentiation of minus 8y is minus 8. Was there any other ones? No. So just on how I got to that first part, it was just always basically the one that is connected to what I needed to look at. Okay. So let's quickly see here. The 2x, so that was how I got to the 2. I think that was the last one. Yes. Okay. So just nearly, because I think I did not mention that every time. So again, that was that part that we did there. Okay. Just that if I can't remember if I did mention that. So that is how we jumped into that. Okay. Okay, so that is the end of this session, but that is what we were supposed to do last week already. So let me quickly save it. I will resend this with some of the scribbles as well to the group. So basically, in the practical part of and what they call the application of integration. So what now we bring back nearly what we've done in study unit 3 and 4, where we looked at the cost. So total cost, marginal cost. Remember when we started with differentiation, I had that one table that I said, well, we will differentiate moving from a one to the other one, and we will just do the opposite to integrate. So that is basically what we are doing in this process. So that for me is nearly always, let me quickly go back to that one. Sure, that was, which session was that? I just want to get that table again. So just to, I don't know if it was in this one or if it was as a. Okay, so basically what we set in this one, and let's just, and can you guys still see the new slide with the table? Just want to make sure if you can still see the slide from, okay, awesome. Okay, so remember when we did this with the differentiation, we said, well, we're gonna, if we get the total revenue and we need to get the marginal revenue, we will differentiate. Okay, so now what you will do is they will give you the marginal revenue and you will integrate get back the total revenue. So in study unit 6, we basically moved from total revenue, total cost, fixed cost, variable cost, the combination of that. If we needed to get to the marginal revenue or marginal cost or marginal variable cost, we basically did the differentiation of the totals. So now to move back to the totals, we will need to integrate the marginals. So that is nearly, again, just showing us how the two are linked again. So from total cost to marginal cost, we basically did the differentiation. So now to get from marginal cost to total cost, we need to integrate again. So if we get a function like this, so let's say they tell us, so the marginal cost function is 10 over Q. We need to work out what is the total cost. Okay, so first we will need to integrate that. So to integrate that is basically saying, okay, it is, let's just write what we're going to do. We integrate that. So that answer then is, and let's make it easier for ourselves to understand that. So if we integrate, I take the constant in front. 1 over Q becomes ln. And then just remember the C. So that will be your total cost. What is very interesting nearly is that they would then ask you, so if I only ask you the total cost function without giving you extra information, that is your total cost function. Okay, so I think that is just, again, important, depending on what they want nearly, or what your answer will be. You need to basically it's not you need to decide, depending on what the question is, you can end there, or they must give you more information. So the more information that they can give you is to say, okay, so the total cost is, so in this instance, they said, if you produce 100 units, your total cost is 500 Rand. So then you know, okay, 500 is my total cost. Q is my unit, so that is 100. I don't know C, so that is what I'm actually going to calculate in this instance. That you work out with the calculator. There's no ways one can remember or know what that is. So 100 ln is 4.6, and if I times that by 10, I get 46.05. It is positive on this side, so if I take it over, I must subtract it from 500. So the C that I would have gotten is that. And now I can substitute that C into that formula to get to my total cost formula. So again, depending on what they give you, we need to, or you need to decide at what point you're going to stop. So if they want you to work out this type of equation with a C worked out, they need to tell you 2 points. They need to tell you what the total cost is, and they need to tell you at how many units you needed to make that total cost. They can't, again, you can't thumbsuck it or guess it, because then you won't get an answer. Okay. So that was the total, so from marginal to total. So the same nearly for, so that was total cost. The same principle for total revenue. So total revenue, they would need to give you the marginal revenue. If they want you to work out the total revenue. So they would need to tell you, okay, my marginal revenue is this. Okay, then you need to integrate that. So if we integrate that, it will become 100 Q minus 4 Q to the power of 2 over 2. So that we will now simplify that and remember the C. So it is 100 Q, and there we have that. So basically, that is just a very, very easier way of doing the integration. And then again, when you have this, so you know this is now your total revenue. If they want it in that format, they would need to give you more information. So then they would need to tell you, well, my total revenue is that when I'm selling that number of units. Again, they can't expect you to go from there to there without giving you other information. Okay, so just to be clear, they can't expect you to go from there to there without giving you information to work out the C. In this instant, the C was 0, but that is pure luck. So please don't think it is always like that. This one was just pure luck that it is the same. Okay, so just I just want to warn you. So it just looked like very easy, but it's actually just because the numbers that they use. So if I want you to write it in that format, you will need to get the total revenue and the Q so that you can replace it in this formula. Okay. So then what they also talk around is the rate of change. So basically nearly the slope. So this basically comes down to what we've done in the previous chapter as well. So, and there was 1 or 2 questions like this in the assignments as well, and you will probably get one of this in the exam as well. So they would talk about rate of change, but they again need to tell you a bit more. So they need to tell you, okay, this is my cost function. So this is my total cost function. So for my total cost function, if I give you the total cost, so let's look at what they tell us. At a small tool hire company, the estimated rate of increase in the maintenance cost of power drills is given by that, where C is rand and T is the time in weeks. So they then need to tell you what is the maintenance cost for the first 5 weeks. So again, it's not something that you can just guess. They would need to tell you, even if it is for the first 4 weeks, they need to tell you between 2 points so that you can say, okay, I need to basically integrate that. So my integration of that will be, okay, again, it's split, so we can integrate that and we can integrate that one. So if I integrate 2, it will become 2t. If I integrate that, just so that is 2.5, so we will need to divide by 2.5. Just nearly, there's a difference between if it was that, because then you're actually working with the e function, so the exponential function or the e. So just remember, this is a normal, if it was x to the power of 1.5, you would have just added 1. So just because now suddenly it looks weird, don't assume it is the same as that. So you still follow the same process as if it was a X or a U or whatever it was, so that you just say it is T, it was 1.5, so remember we add 1, so it will become 2.5, but that answer then we will need to divide by 2.5. So that is the integration. So we basically have integrated that now. So now it will be, okay, between 2 points. So for this one, they said between 5 and 0. So you will work that out. Then they've asked between 10 and 5. So you will still, that formula would still stay exactly as it is. What you will now just do is, and as was said, the biggest one at the top, the smallest one at the bottom, replace the 10 in, get the answer, replace the 5 in, get the answer, and subtract the 2 to get to that answer. So basically, if you work with this rate of increase or rate of decrease, if there was maybe a minus, remember that they will then need to tell you timelines. So they will need to tell you so if they said to you, what was the rate of change for the first 2 years? Or say for the first 2 weeks. In this instance, we're working with weeks. So if I set the rate, you need to work out the rate for the first 2 weeks. You know that, okay, so the maximum or the big one is 2, and we're starting off at 0 because we want to know for the first 2 weeks. If I said what is the rate of change for the first 10 weeks, it would have been 10 at the top and 0 because we start off at 0. So it's not that they always need to give you the 0, because it can be that they say nearly from now till, so what is the rate of change for the first 4 weeks? Then it is 0 to 4. It's only when they want us to work out different periods. So if they want us to work out what's the rate of change between week 6 and weeks. So if I said, what is the rate of change between week 6 and 7, where would you have put the 6 and where would you have put the 7? So always the big one there, the smaller one there. So if I ask you to work out, brilliant. So if I wanted you to work out between week 6 and week 7, that is what you do. So, and they can phrase it differently. So they could have asked you what's the change between week 7 and 6, still 7 at the top, 6 at the bottom. Okay. So it's nearly, if I don't say what date or what time it starts, then it's nearly, okay, for the first 4 weeks or first 6 weeks or first 7 weeks, then we know it is 7 and 0 or 6 and 0 or 4 and 0. But if they are very specific, like in the second part, then we know it's between 5 and 10, 10 at the top, 5 at the bottom, subtract the 2 when you've worked it out. Okay, so that is just again nearly wanting to give you a bit of more nearly information that you will need in the exam. Again, here they give you the formula. So first of all, now, okay, so it's e to the power. So now we need to remember, oh, what is that rule? So basically e to the power, it becomes, so that normally stays the same. So that will stay the same, and we will divide by whatever is before the t. And this one just now looks very weird because it is with decimals. So remember, if it was that and we needed to integrate, so let's say that was a 2, let's just make it so if we needed to integrate that, remember it would have given us 2t divided by 2. Okay, so yes, please, Desmond, ask before we go on this one. And you can unmute yourself. You don't need to type.
Hi there.
Yes.
So the slide 2 above, the one that we were busy with now with the T10, yes, that one.
Yeah.
And that one that you showed us now. So my question is, if we had the 10 at the top and the 0 at the bottom, then we would have gotten the 146. Can you go back to that one, John?
Let me quickly, not this one, eh?
Yes, it's that one. It's that one. So the 10 at the top and the 5 already gives you 114. So that just confused me a bit because Only if I had put the 10 at the top and the 0 at the bottom, it would have given 146.
Okay, so yes, okay, so let me quickly, so what happens?
I understand what happened. Sorry to break your word. I understand exactly what happened, but the way that they've done the calculation would throw people off because it's confusing. Then they would rather have had said you get the total for the full duration of 10 and then you subtract the first 5. But I mean, if you read what they say during the following 5 weeks, the total maintenance cost was so the next 5, and they've done everything correct up until the point where they put in the 146 minus the 32. Because if you had the 10 at the top and the 0, then it would be 146. But if you have the 10 at the top and the 5, it immediately goes to 114.
Okay, so let me quickly, so they basically, so from 0 to 5, it was that 32.36. Then from 0 to 10, it was for 140. So when we worked out only for the 10, we got this. When we worked out only for the 5, we got this. The reason why, and it's again purely by what is in the formula, because there's a T in both, and this is nearly by fluke. So the way this is set up is that when you put in the 0 in the T, that would automatically make it 0. So this is actually a bad formula also to show you, because here the 0 will always be 0, because when you multiply by the T, the 0 by the T, it will always be 0. And that is nearly, so that is what was a bit confusing with this one as well, that it is, the 10 will basically, that will be for the 10. And that part will be for the 5. And by fluke, the 0 was also 0. So it nearly, for this one, it was a bit a weird one, because it is coincidental that the 0 was 0. And it's not always like that. So I think that is also the one thing, is nearly one needs to go through the processes, because it's not always that if you put in the 0, it will just be 0. Because if you look at this formula, if you have the 0 in there, it will actually give you an answer. So it was only with the previous one that by fluke, the 0 changed it to 0. Does that make a bit more sense? Are you happy with that explanation, Nearly, Tasmin? Cool. Because yeah, it's purely because, and that is nearly why I wanted to talk about the others as well, because that is, if you look at this one, we will have for the 0, there will be a value. So rather in the processes, we nearly need to always work out the whole thing. because depending on what your original formula is, so by fluke, this one was nearly, it catch you out, but also confuses you because of that one that nearly disappears, where it's not at all in the ones probably that you will get in the exam. So you will probably get something like this in the exam, and then you will have that the zero will actually give you a value. Okay, I think so. Let's look at this one as well, because again, they give us marginal cost. We need to go to total cost from marginal cost. So if we go from marginal cost to total cost, integration, so that becomes minus Q3 over 3. Again, the minus, it stays a minus. So at least there's no mistake in this one. Integration doesn't change that. Then the 80Q becomes 80Q to the power of 2, and we need to divide by 2 plus C. Okay, so you would see that that is basically what we got here. I would not in the exam change it to a decimal unless it is 0.2 or 0.3 or 0.4, because something like that is a continuous decimal. I won't change that in the exam. I will rather get my answer and divide by 3, just because it can be then that your final answer is out by some decimals or by a point, and then you always worry if you actually did work out correctly. So I would always try to stay away from a decimal that is not a true decimal. So if it was 1 divided by 4, I know it is 0.25. I'm fine to work with that decimal. But something that is continuous, I rather in the end divide by 3 instead of using it there already. Okay, so then when you get that total cost, now basically the same principle will follow. They put in 3, they put in 12. So firstly, that first part is where they put in 12, then minus the second part when they put in 2, and then you will get a final answer. So again, here, if they set between 0, your Q's will again would have been 0. So if I said 0, that nearly would have fallen away because it would have become 0. So that is why the 0, 1 is always, in some instances, not the nice one, because it confuses one, because it basically then makes it at Q equal to 12, or yeah. So just be very careful with that 0, because again, if we were talking here Q0, when we put in the Q, those zeros will fall away, or those Q's will fall away. So you will sit with 0 nearly. Okay. Let me just do that. Okay, so then the next one is the part that I don't like at all, the consumer surplus and the producer produces surplus. So nearly this for me is how I look at it, and I'll explain it with with graphs as well, because for me it's normally easier to work with the graphs. But what they nearly tell us is yeah, there's in certain of the subjects there's like one or two things that I really don't like, and this is the part in this one that is. Um, so with a consumer surplus, I think what is important is you will have the part, the area under the demand curve. So we will look at that now, and then you will basically subtract the area of a rectangle. So you will need to work out the integration part, and then you need to nearly subtract the rectangle, which is a easier area to calculate. When we do the producer surplus, it is the other way around. So you will have the rectangle, and you will subtract then the area of the function. Or the integration one. So I think that is the two differences. So the other thing you will see is when we look at the demand function between 0 and whatever they give us, when we look at the supply function, again 0 and whatever they give us. So it's always 0 to whatever they give us. So when it was a straight line, it was the easy one to do, because we said at a certain quantity, at a certain price, we had the linear line. We know what the consumer surplus is. Okay, so straight line in study unit 4 was a very simple calculation. The same with when we did the producer surplus. Again, was a straight line, very easy to nearly calculate that, because we would have gotten a price, we would have gotten a Q value, it would have been on the curve or on the straight line, easy to calculate. But now when we're working with and what we call it, a parabol, or basically the quadratic function, it looks something like this. Okay, so now we go back to the beginning of the previous chapter. So when we said we integrate between 2 points, so that is basically what we are doing now. So with the integration, we basically, so what that part is doing is telling us, remember what we did in chapter or study unit 7, we integrate between that point and that point. So that is the area underneath that we are getting. So let me see if purple will make it better. Okay, so from the previous work, so if we integrate and we put the 2 points in, the 0 and the 8, that is the area that we get. But for the consumer surplus, we only want that area. So that is why then we need to say, well, we take the whole area and we subtract that part. So if we just do that again, so we take the whole area, which is the integration part, and we subtract the rectangle part. Okay, so that is how we would calculate for consumer surplus for a quadratic demand function. So actually, when I explain it now, it actually sounds a bit simpler as when we originally looked at it. And now you can see why you need to work through the other chapters as well to understand this, because now it's actually very, I don't want to say simpler, but it actually now makes sense. So what you are actually doing is you're calculating the total area, but you only want that area of a consumer surplus at a certain point. And that point is given at the 36 and the 8. So you basically calculate the whole area with your integration, and then you subtract the bottom part. Okay, so that's your consumer surplus. So when we, and quickly ask questions around that, if you want. And does it make a bit more sense now?
I think the part where you said that after, or we have to work through the earlier chapters to make this make sense. I think that makes a lot of sense.
See, so and I think that's why I didn't want to nearly use today's session to go to exam papers. I rather wanted to nearly get into this, because you will get a consumer surplus and or a producer surplus of a quadratic in your exam. So, and looking at it now, it is a bit simpler than when you did it in assignment 3 a month and a half ago nearly, where it was like, how does this fit actually into the picture? Okay, so I'm glad, Cameron, that you feel it's a bit easier. So if you go back to the beginning of the session as well, when it's being put on the group again, it basically just we nearly started with that in this session. Okay. Somebody else also, Tasmin, did you want to ask something on this, or is it a bit clearer now actually? Oh, Eva, if you can maybe post that question, it will be nice to look at. But it is probably yes, Cameron.
So I just want to know, like, in assignment 3, there was like 3 random marks given to us. So, like, I just want to know what happened in those questions where they gave us those marks.
So it could be that, do you know, did you guys get the answer sheets as well to the assignments, the physical memos? Because it could be what happened is that somewhere one of the answers was there was a mistake maybe in it, and they gave everybody 3 points or something like that. And that is nearly what happens in the exam as well. So okay, so that was probably, and the other thing is, in this exam, as you would have seen in the paper that was written last year, there are no more the none of the above. So, and also then what will happen in the exam, if I pick up a mistake, they will give you the 3 points, or they will let the paper count out of, instead out of 30, they will count it out of 29. But normally it's easier to give you the 3 points than to recalculate now something out of a different value. So that is normally why they give you that 3 marks, is because there was an error in one of the answers. Or there was more than one answer or something like that. But again, if that happens in the exam as well, they would give you that points. Okay, so, and that is the other thing, that from last semester, the none of the above, they have taken that out of the equation. So it was still part of the assignments, but because the assignments was printed and created at the beginning of the year, that is just why it was still part of it. But again, yeah, because I also hate the none of the above kind of options. So basically you would see it doesn't matter what graph you have. So this one was, that was your demand function. Your demand function can look like this as well. What you need to do is get the integration of that and then subtract the bottom part, or subtract the rectangle. So that is how it will be the whole time for consumer surplus. So always consumer surplus is basically the integration part calculates that whole area. And because you say it is between 3 and 0, it calculates that whole area. Then you need to take away the rectangle part so that you are only left with the consumer surplus part. Okay, so that is nearly how all of these questions will be. Integrate of that, and then remember to subtract the rectangle. So they need to tell you what that Q is. They need to tell you what that price is. Again, you can't miraculously come up with an answer. It is not that there is 2 functions that now suddenly join one another or anything like that. They need to tell you that is that point so that you can work with it. You can't miraculously come up with those numbers, because you won't be able to do that. So they will need to give you those answers. Okay, so how, and let's quickly look at this one. So they gave us Q3, so we could have put Q in there to get the P. Okay, so the same we did with the linear equation. Sometimes they give you the Q, you work out the P, the other way around. They can give you the Q and you work out the P. Okay, so what they did with this one that you shown, question 11. So this is actually a straight line. The demand and supply functions for a product are given with P in quantity by working with values. So this one will actually be what you showed now, is two straight lines. And then you would need to work out, in this instance, question 11, the producer surplus. So the producer surplus would have been that part. Okay, so that one was ever that you posted there was a straight line. I think we can look at it maybe afterwards just to check, but it looks like a pure straight line for me. The demand and the supply functions, but we can, hopefully there's not a catch in that one. Okay, so I'll look at, okay, so how do you know the difference? It basically, your demand function, so when it is not a pure like this one, that, so I just want to write down that so I think that one was the, okay, so that we know nearly is a straight line. So when it is two straight lines, you work with the normal way. If by just doing that, it's not a straight line anymore, and we will do this. If it was, so just by, let me quickly change it just a bit again. So that was for regional. Just doing that, it is not a straight line anymore. And that is nearly what we probably have in this one. So just by changing the formula a bit, it's not a straight line. So I think that the easiest to see it as is when it is, when the Q is just like that on its own. So it can be a small Q as well. It doesn't need to be, but if it is like when we have a normal mx plus c, so if that was, so nearly anything that looks like a straight line, if it becomes anything that you can suddenly see, but okay, now we're not dealing with a straight line anymore, that's a square root, so it's a non-linear. If it is quadratic, it's non-linear. If it is to the power of 3, it's non-linear. If it is something like that, it's non-linear. So that is nearly the way I see it, is when anything is non-linear, then it becomes that we work with this kind of functions. And it doesn't always need to be quadratic. Here it was hyperbolic, so I don't even know what that nearly is. So you also don't even need to know what type of function it is, but here you can see it is not a straight line. That is not a straight line formula. So that is nearly the way that I look at it. Okay, so now you understand the straight line better as well. So that's an extra bonus. Yeah. So again, the concept is very, in a sense, very similar. So in the consumer surplus, we calculated that part. So we could have had it that we add that whole area, take that and subtract that. So consumer surplus, basically the top part that we are looking at. The producer surplus is changing it a bit, but still you have a rectangle, you have the supply function that you will need to integrate. So when we had the original linear equation, so now again you can look at this one, straightforward linear. If you look at that, there's no to the power of 2, you're not 1 divided by anything, it's not a negative with a q, it's not that it is something like this, it is straightforward, a linear line. So then it was, so there would have been another line coming through here, which would have been the demand side. So the consumer surplus would have been that part. The producer surplus is basically the bottom part of that. So the same when we look at the producer surplus part. So the difference is that what we would have done with a consumer surplus is, so here would have been a graph going, and let's make it now. So let's say I want to draw it now, that it's not a straight line. Okay, so that would have been your, for your consumer surplus. Then for the consumer surplus, we would have wanted to work out that, and we would have said, okay, then we subtract that rectangle part. So now for the producer surplus, what we are basically doing is saying, well, there is my rectangle, and I need to work out that part. So that part is the smaller part. So then I say, well, okay, my rectangle part I will work out, and then I will subtract the part of the integration. Okay, so again, if we had the, if it was just assume, wait, that doesn't let me, I want to draw a straight line, so, or nearer to a straight line. And then I want to add in here, if we had the consumer surplus one as well. So if we did the consumer surplus, it would have been sitting here. So if we did it in the straight line part, the consumer surplus would have been sitting here. The producer surplus would have been sitting here. So again, the similar concept, consumer surplus is sitting there, the producer surplus is sitting in this part. The only way we can work that out with a function that is nonlinear is we will need to get the integration. Remember, the integration basically gives us, so what the integration part will give us is this whole area underneath. the same when we did the consumer surplus. Where was it? It gave us everything underneath the curve. So with a producer surplus, it gives us the part underneath the curve. So there is our curve that's going through there. So it gives me that portion. So I want to get to that portion. So how do I get to that portion? I will need to say, take my total rectangle, that's the bigger component. I subtract, it was actually not that part, I subtract the part of the integration, which will give me the below the line, to get to that part. So it's basically just for opposite, where you would have had the consumer surplus, subtracted the part that was the rectangle to get that. Here we basically say, take the rectangle, subtract the part that you have worked out from your supply function, and that will give you your producer surplus. Okay, so the thinking is a bit different, but it's nearly the same principle. You just need to remember what you are after. And with this one, you want to get this area. So how do I get this area? I say take my total area and I subtract the part that my integration worked out. Okay, bit different, but it's nearly the same principle. Okay, does that make sense? Does it make more sense, or bit simpler, or bit easier, or total confused?
I like how you visualized like the whole, you take the rectangle thing and then you kind of like yeah, where you were gonna subtract the triangle from the rectangle for the part you want.
Yes.
But like, cause yeah,
So
I
it's
think that's
nearly
really cool because
that.
everything in this module is easier to understand when you make it visual. So
Yeah.
when I get a, yeah, so I think that that was really cool. It's in a different way that I can look at it now.
Yeah, and that is, I see Norma was on this one last year and she's now doing the stats, but that is nearly how I do it with the stats as well, because you need to, when you do graphs, you need to nearly visualize it for yourself to make it easier. Yes. I also want to now click yes. So yeah, so that is why with some of these, I can only work with nearly if I visually, because then you can also sometimes see when you get an answer that it just sometimes doesn't make sense. So if you swapped this around, you would get something negative, and you can't have a negative area. So it's the same nearly for some of the previous work that we did. If you look at price and quantity, this now is looking nearly back at some of those linear equations, and where was that study unit 4 or 5 or even 3, when it was you need to complete so many chairs within hours, so many tables within hours. So there's certain things that you can't produce a negative item. So the same here, you can't have the area that is negative. So if you by mistake said, take the integral minus the rectangle, you would have gotten a negative answer. Then it's nearly, you need to think for yourself, okay, but it can't be negative. It's like you can't have a negative. It's the same when we were, okay, it was in the previous chapter nearly, where we had in this one. So with this, you can't have a negative. So you will not be able to have a negative. Just also because that is to the power of 1.5. Even if you had -1, so you can't go back in time nearly. So this will never be negative. So if you get something in here that says your total cost is negative, then you need to say, oh, flip, maybe now I did swap these two around. And that is why I'm getting a negative. So it can't be. So if you had in this one said it was 0 and that was 10, you would get a negative answer. But then your total cost can't be negative. Phew, that would actually be awesome if you're actually getting money to and not so but that is also nearly what you need to. There is some logic in some of these as well. I know it's a difficult subject, but there's sometimes when you suddenly have produced 1.5 chairs in your answer, it can't be one of your answers. So when we do the calculate how many things are produced and it was a quadratic, sometimes you have a negative answer for one and a positive for the other one. So then in your answers, it can also be that they give you a negative and a positive, and the next one they only give you a positive. And from a mathematical point of view, we would have wanted to say, yes, x is equal to -1 and x is equal to 2, because that is what the math says. But from a production point of view, you can't produce a negative table. So it is those kind of things that one also just need to look out for, and that is why certain of these things is very difficult, because it's not something that we work with every day, and it's the maths is, if you had maths, it was way back when you did it. If you did the integration, it was probably even further back that you did it. So it is 4 minutes per answer in the exam. So in the exam, you have basically 4 minutes. Yeah, it is close. So and that's why. So let's look at. So at least the none of the above will not be in anything anymore. So you will only have 4 options. What I told some of the students, and on the group, I'll start getting Muhammad involved again in some of the discussions as we get nearer to the exam. But there are ways that, so I'll show it again in some of the assignments that we will do on all the exam paper on Monday and Tuesday, what we used to call the Scully method, and that is nearly to eliminate some of the answers. And we've also started, you would see sometimes I joke about it, but if you don't know the answer, guess option 3 or option C. So we'll do that in the when we practice the exam paper. So let's quickly let me quickly see if I can, because we are finished with this study unit. So I just want to see if I can quickly.
Just before we go, can I just get those the times and the days that you said next week for we're gonna do the exam prep, or you're gonna send us those times again?
So UNISA will basically send an update after today's session again, but it is supposed to be Monday and Tuesday from 4 to 5:30. So basically an hour and a half for Monday and an hour and a half for Tuesday. But we still have a few minutes, so let me quickly, Eva, you put this one on. So let's quickly look at this, and so the consumer price index of a country is appropriated by this function, where T is the number of years from now. Approximately how long will it take for CPI to reach 220? Okay, so this is something that we would have done. So this is not to work out consumer surplus or producer surplus, but this is that rate of change that we did somewhere in this. So firstly, we need to get the integration of that. So what is that number integrated? Okay, so I would have said, and now that we've worked through some of these things, was it something like that? Would that have been the integration of that? What do you guys say? Let's quickly see where was. So basically when we integrated that, it became the integration. That was still there, so we just divided. Okay, so that is what I would have done here as well. And then I would have done it for T0. Oh, see, so so this is now a difficult one. So if T was 0, let's quickly just want to check what is e to the power of 0. So what is, okay. So this is an interesting one. So I wanted now to say from 0 to whatever, but they're nearly telling us the integration, how long will it take to reach 220? So I would say, let's just do that. And the reason why I say that is if I put in 0 there, 0 times that would have given me 0 e to the power of 1. E to the power of 0 gives me 1. So that will basically become 170 divided by 0.03. So this is an interesting one. So let's see if I would have. Okay, so we did the integration correct. There's no problem with that. So what I would have personally done here is what Muhammad would have called the Scully method. So I would have put in 4.5 in there. So I would have said 0.03 times 4.5. Let me just clear my calculator. So 0.03 times 4.5, that would have given me 0.135. And if I say e to the power of that, it gives me 1.1445. So I will multiply that by 160.3. And if I divide that by 0.03, why does this not seem like a very good example? I'm now struggling with this. What did you guys do with this one? What would you have done with this one?
Which assignment was this in? Which assignment was this from?
This is the May-June 2017 question paper.
Oh. Oh. No, I don't know. I would have just followed the hints if there was hints. That's what I would have said.
Okay,
No,
there's no.
that is interesting. So if I would have, yes.
So John, what I've done is I've put in the 220. I've equaled that 170.63 e to the power of 0.03 t. And then I've times both sides by 100.
Okay.
So I've got that answer, which is 22,000 equals all of that. And then I've divided that by 17,063, which got me to 1.289 equals to e to the power of 0.03 t. And then I've used the ln option, times that by 100 divided by 3, which came to 0.253 times 100 divided by 3, which gave me 8.46, and I've rounded that off to 8.5.
Okay, so let's quickly, so what I would have done, so I will check it as well. So I would have said I integrate, and then I will put it equal to 220, which is probably not the right way. So then I would have said if I multiply that then out there, 170.63 e 0.03 t will be equal to 6.6. I'd probably go the same route as you. So I would divide that by 170.63. So I will take that away on this side. So let me quickly see if I... So out of that I get E 0.03 t is equal to 0.03868. So then I would have set ln on both sides, so that So that answer, Lynn, so I would have now gotten a negative. T is equal to negative 3.2524. So I would definitely go and check this again. I would have then divided it by 0.03, which would have given me 108 years. So yeah, so I think 8.5 was correct. Because I think I've got somewhere some of the notes on this one. So I think the 8.5 was the correct one. So let me also just go back and do this properly, so that we can get to the right answer. But you did integrate it, or not? Or did you work with the original formula just?
If if if
Why?
if I did this paper right, I would look for a similar question, and in our book, and I would look for what the steps is to follow. And if they say you integrate first and then you find the answer, then I would follow those steps. I don't know what she did though. She's not talking now.
Yeah, I just want to, if this is, so why, let me just think, why did I need to integrate? Wait, let me just do this. So I'm gonna use my, I'm not gonna write that everything down. I'm just quickly gonna use my calculator. So 220 divided by 170.63. So that gives me 1.2893. So if I basically had that part that is equal to 1.2893, I then take ln to get rid of the e. So that is equal to 0.2541. And if I then divide that by 0.03, I get 8.47, which then
She shared her answer. She shared her answer in the
okay,
group, and it looks like she did exactly the same thing you just did, yeah.
okay. So that is nearly also the thing ever that one must be very careful is I just assumed we need to integrate, but they didn't ask us the rate of return. So, and I think that is important nearly when we did the work in the other part, they said to us, work out the rate of change or the rate of from 0.0 to 0.5. Here they're just asking us with that formula, what will be, after how many years will you reach 220? So after how many years would CT be equal to 220? So this is a straightforward mathematical question. No integration, no differentiation. You basically, if it was in maths, it would have been solve for x. Okay, so that is nearly a difficult way to put it, but how to use your ln function when you have an exponential. So one is very easily, I just automatically, when I saw that, I was like, oh no, I need to integrate. I know how to integrate that, but it actually, that's not what we needed to do. We just needed to solve CT. Okay. Does that make sense?
Yeah, makes a lot of sense.
Okay. Cool, guys. So that was the session today. We will be back on Monday, back on Tuesday, so that you can, I think you're writing on Thursday, so that you are prepared for Thursday. Great. Let me quickly stop the, it has been a long session.